Welcome to lesson number 6, Learn C Programming on the Raspberry Pi. Okay, last day we were talking about functions, and today we're going to continue our discussions about functions. Remember that a C program is made up of functions. Dozens, hundreds, thousands of functions make up all kinds of C programs. So it's important to learn how to use functions, how to create them, how to use them from the libraries, etc. So as you can see, I'm already on the Raspberry Pi, and I'll bring up Genie and look at the last program we worked on. Okay, there it is. So let's just take a few minutes just to go through this again. Here we have our main function, and our main function has a for loop that calls this function called myHello 10 times. So myHello is described up here, and if we look at myHello, the actual code for myHello, we see that myHello calls the printf function, and it also calls myGoodbye, and the prototype for myGoodbye is up here. So let's just once again build this guy, and we will run it. Just so you can see what it does. So it's printing out, we start at the top here, 0 hello world, goodbye world, 1 hello world, goodbye world, etc., etc., all the way down to 9 hello world and then goodbye world. So 10 times. But let's look at this idea of call by value. What does that mean? Well, what it means is that whenever a function is invoked or called or activated, the actual parameters, I here in this case is an actual parameter, is copied to the formal parameter xyz. Okay, so here's two more kind of important words to learn. Maybe I'll just write them down here. I is the actual So I is the actual parameter used by myHello right here. That's the actual parameter that myHello uses. Of course, down here, let me just put a comment in here. XYZ is the formal parameter used by myHello. Maybe I should just make that all caps. Okay. So when we look at call by value, what it means is the actual parameter or parameters, if there's more than one, are copied to the formal parameters. And another note we could make is some people use the term arguments. Argument or arguments instead of parameters. So sometimes you'll see these being used interchangeably. You know, what is a parameter? What is an argument? They're basically just data values, pieces of data that are passed between functions so that functions can communicate with each other certain kinds of data. Okay, so I want to leave this example here. I've saved it, but I just want to make another example going deeper into functions. So let me make a new file here. And this time I want to write a function that converts inches to centimeters. Now we did this in a previous example, but now we're going to use our own function. So, and I'm going to use another library function so that we can read in the data we want to use. So let's see how this is going to work. I'll say float inches. Float. You know, to save time, I think I'll just call these guys by their abbreviations. Float inches and float centimeters. And now I'll do a printf. And I'll say enter number of just to convert to. Please enter the number of inches to convert to centimeters. Space, quote. In fact, I think I'll take that please out just to make the line shorter. Okay, enter the number of inches to convert to centimeters. Now what I'm going to do is I'm going to use another library function called scanf. And what I want to do is I want to scan in the person's answer. I want to read from the keyboard the person's answer. And I want to read it in as a float. So I want to scan in one float. So that's the format, %f, and I'm going to read it into, and this is kind of tricky now, I put an ampersand in front of, I want to read in inches, I put an ampersand in front of inches to say the address of inches. So let me put a comment here, ampersand in means of inches. So in other words, when the person types in a value for the inches, that value will be stored in the computer's memory at the address specified by IN. So remember, all of these variables, we only have 2 of them, they all occupy space in the memory. So each one has to have an address. The computer has to know where to put it in the memory. So when I read something in using scanf, again, this is a standard C library function, then I want to know where to put my answer. I want to put it in the address of IN. Wherever IN is in the computer's RAM, in the memory, then that's where I want to put my answer. Okay, so I'm going to read that in. Once I read that in, I'm then going to compute the number of centimeters using my own function. And I'll call this in to inches to centimeters. And it's going to take one float, which is inches. What that means is I should put a prototype up here for that. So I'll say FLOA float inches to centimeters float. So if you look at this definition of, here's the name of the function I'm writing, and it's going to return a float number, which is the actual number of centimeters, and it's going to give a float or receive a float from the main function. So here the main function is going to give this float to this function so that it can work on it. And then I'll say printf quote, and I'll say %f inches is %f inches is %f centimeters. And I'll say IN and CM. I'll print them both out. I'll even put a new line at the front here. Oops. A new line this way. And then I can end my main by saying return 0. So I'll save this guy. File, save as, and this is lesson 6. So let me go to lessons, and I will create a folder here called lesson-06, and I will call this let's see, inches to centimeter.c. Okay, so there we have it. Well, we have everything except we don't have this function coded. So I'll do that right here. Notice it's going to return a float inches to centimeters, and float, and I'll call this x. I could call it anything at this point. Okay, and so now I'll just say, well, let me do it this way first. Float result, and I'll say result is equal to the number of inches, which is x, times 2.54. And then I can say return x, the float. Save it. Okay. So let's just take a look at how this program works. We're introducing a new function here called scanf. This is part of the standard C library. Very similar to printf, except that the difference is that when we scan in a variable, we have to give it the address of where we want to put it. So hence we have to use this little ampersand, which means address of inches. Okay. But we still have a format specifier here. Just like in the printf, we have this is our format specifier. Okay. So when we run this program, main starts off, it calls printf, so it prints this on the screen. Enter the number of inches to convert to centimeters. That's printed on the screen. And then my program will stop. And it will wait for me to enter a floating point number. And that floating point number it will store in the address of the variable in. Once it reads that in, then it will call this function. So main will then call into cm, and it will use call by value mechanism to copy in to x. So in is copied to x, and then this function is executed. Well, this function then says, okay, I have a float here called result. Result is x times 2.54 and return x. So the return value x is this float here, which is then put into this variable here. So into cm is finished, and then we go to the printf and we print so many inches is this many centimeters, and we return 0 and the whole program is over. So let's see first of all if it compiles. Oop, float result is not used. Oh, instead of return x, I should have said return result. I want to return the result, which is the number of centimeters. And you notice the error message here says, well, you have a variable result, but you're not using it. So it was just declared here, result was evaluated here, but I never really used it for anything. Now I'm using it as the return value. So let me go here, let me go to the build again, and this time compilation finished successfully. I can now execute. And you see it comes up and it says enter the number of inches to convert to centimeters. So if I say 12 inches, and it says 12 inches is 30.48 centimeters, which is, I believe, the correct answer. Okay. So, a lot of interesting things happening here. Number one is, since float, the code for float comes after our usage of it, or our code rather for into cm comes after our usage for it, we have to give this prototype up here to say this is how this function is defined. It has one float argument or parameter. It has a float return value, and this is the name. So it starts off again executing. Main will execute, and the first thing main does is it prints out this message. Then main will stop. The question is, how long does it stop? Well, it stops until you hit the enter key until you type something in. So it will wait for me to type in an inches value, and once I hit the enter key, then this scanf function is completed. I will then call the into cm function. But before I call it, before it gets activated, in is then copied to x. Once that takes place, once that copy takes place, then into cm can now run. It can now execute. So it creates a result. It works out what the result is, x times 2.54, and then it returns the result to the program that called it, which is the main program. So in the main program, this return value is put into this data item. And then we go and we call the library function printf, and it prints out the inches and centimeters, and then main returns a 0, and we're all done. The program's over. Okay. So this is the way how you get information into a function. You get information into a function by copying the actual parameter to the formal parameter. Or you could also say copying the actual argument to the formal argument. So that gets information into this function. How does this function get information back to main? By using the return value. The return value is going to be the value of the function. So this whole function, after it executes, it's replaced by the return value, which is 30 dot something. And that 30 dot something is put into this variable here, cm. Okay. So data going in is called by value. Data coming out is with a return statement. So now that we know we can get information into a function, and the function can return information back to the program, back to the function that called it. Okay. Okay. So this is a short lesson. I don't think there's anything else we need to cover today. But I do think that you should start thinking more about what this ampersand means, and you should also start looking at formal parameters, actual parameters, and how to use the return value to get information back to the calling program. Okay, that I believe is it for today. So thank you for watching and listening to lesson number 6. And lesson number 7 will be available shortly, and we will be continuing our discussion on functions in the C programming language.